Section 7.2, Example 2 on page 443, we have the terms point, line, and plane are not defined because their definitions would require terms that also need defining. You can, however, use undefined terms to define other terms. A geometric figure is a set of points. Space is the set of all points in 3 dimensions. Similarly, the definitions for segment and ray are based on points and lines. A segment is a part of a line that consists of 2 endpoints and all points between them. You can name a segment by its 2 endpoints, such as segment AB or segment BA. So you can start on this end and say AB, or go the opposite direction and say segment BA. A ray is a part of a line that consists of 1 endpoint and all the points of the line on one side of the endpoint. You can name a ray by its endpoint and another point on the ray, such as ray AB. So here we have an endpoint, and we're going to continue on forever in the direction towards B. The order of the points indicates the ray's direction. So you always start with your endpoint and use another point that is on the ray. Opposite rays are 2 rays that share the same endpoint and form a line. You can name opposite rays by their shared endpoint and any other point on each ray, such as ray CA and ray CB. So we will start both at the point C, which will be the endpoint for the ray, and we can say starting at C going forever towards A is 1 ray, starting at C and going forever towards B is another ray, and if we put these 2 rays together, we would get the line AB. You could say line CB, line BA, but this is an example of opposite rays. Example 2 for part A says, what are the names of the segments in the figure at the right? I've gone ahead and highlighted the different segments in different colors. So first we have this small segment from D to E. So we can say segment DE, or you can write it the opposite direction and say segment ED. Then we have segment EF, which can be written as segment EF or segment FE. And our last segment is the entire length from D to F. So we have segment DF or segment FD. Part B says, what are the names of the rays in the figure? Similar to part A, I have highlighted the rays in different colors. If we start at E and go towards F, we will have ray EF. We can also start at E and go in the opposite direction towards D to get ray ED. We can start at F and go in the direction of E, which happens to also be in the same direction as D, so we can call that ray FE or ray FD. Those are the same ray. We can do the same thing if we start at D and go towards E, which is also going towards F. So we can say ray DF or ray DE. Those are the same ray as well. Part C says, which of the rays in part B are opposite rays? And then we have all the rays listed. This time I have only highlighted the opposite rays from the previous problem. Notice that if we start at E and point towards F, and then start at E and point towards D, this covers the entire line of DF. So rays EF and ED are opposite rays. They create a line and they start at the same endpoint. The work for this problem is written out on the next few slides. And now I would like you to try numbers 3 and 4 on page 443. Use the figure at the right for exercises 3 and 4. Number 3 says, what are all the segments you can name in the figure? Number 4 says, what are all the rays you can name in the figure?